distance 3r. So point at a distance 3r, it has the kq by 3r you have to subtract, that is from the surface, and it is kq by 3r. This is defined as V. It is not the V at that point. Potential difference between surface and potential at point 3r distance, that is defined as V. This difference means here is some potential, say V1, here is some potential V2, then V is defined as V1 minus V, that is defined as V here. So it will become 2 kq by 3r. Now you have to take the E by V, that is kq by 9r square into 3r by 2 kq. So E equal to V by 6r. Initially I thought that V is mentioned at the distance 3r. If the potential difference between its surface and the point at a distance 3r from the center is V. Okay. Then 81. Voltmeter reading 0 means terminal potential drop across the first cell is 0. This is first cell, E1, R1. This is second cell, E2, R2. External resistor R. So across this, if you connect this voltmeter reading is showing 0. Okay. For that, what is the relation between R1, R2 and R that we have to find out? See, initially we can consider there is a current I in the circuit. This current I can be written as both E1 and E2 are same, EMF are same, so it will be 2E. E1, E2 same means it is 2E divided by R plus R1 plus R2, total resistance. Okay. Now, terminal potential drop across the first cell means EMF of the first cell minus lost volt. Lost volt means I into smaller one. So this V will be E minus I R1 across the first cell. Lost volt means voltage drop across internal resistance for the lost volt. Now it is mentioned in the problem that this is 0. So we can write E minus IR1, and accordingly we can write E equal to IR1 then. Okay, now substitute the expression for I here. So it will be E equal to 2E R1 divided by R plus R1 plus R2. Then E will cancel. It will be R plus R1 plus R2, that is equal to 2R1. So R will be equal to R1 minus R2. Then next question, again from radioactivity, that is not in the syllabus. 83, that is again not in the syllabus now, but still we can find the answer. It is between 88 to 108 megahertz. Radiometry 98.3. Next one, 84, calculate. self inductance L equal to mu naught N square into A divided by length of the coil, length of the solenoid, L naught. Now, how many meters of the steel wire are required? This is the length of the solenoid. Okay. Now we know that length of the wire required. So for that, if there are n turns, then n into 2 pi r, that will be equal to length of the wire. L naught is not the length of the wire. L naught is the length of the solenoid over which wire are wrapped. If you stretch that wire, then the length is L, not L naught. Now, we will substitute it here. So it will be mu naught N square. N means mu naught by L naught will be there. N square means L square divided by 4 pi square R square. Okay, this is the value of N square. N square will be L square by 4 pi square R square. Now A we know that is also pi R square. Then R square cancel, 1 pi cancels. Then we have to find the value of this L square. This is the value of L. Now L is given 1 millihenry, means 10 to the power minus 3. Mu naught by 4 pi, that is 10 to the power minus 7. Mu naught by 4 pi, that is 10 to the power minus 7 into L square by L naught. L naught is given 100 centimeter, means 1 meter. Then from this we can calculate that L square equal to 10 to the power 4. So L equal to 10 to the power 2, which is 100 meter, means 0.1 kilometer. Okay. Next one, calculate 85. That one is easy. Refractive index is defined by the ratio of the speed of light. So it will be 5 by 4 equal to 2 into 10 to the power 8 by that medium. That say first medium is 1, second medium is 2. So first medium speed of light is given. In the other medium the speed of light is then v2. Then calculate v2. So v2 will be 8 by 5. That is 1.6 into 10 to the power 8 meter per second. Now from this you cannot decide, because there are two values of 1.6 into 10 to the power 8. So you have to calculate the wavelength for the correct option. V equal to n lambda we know, but n is remain constant. So V by lambda is frequency that will remain constant. So we can write V1 by lambda 1 equal to V2 by lambda 2. Just substitute. V1 is 2 into 10 to the power 8 and lambda 1 is given 500 nanometer. V2 is corresponding 1.6 into 10 to the power 8 divided by lambda 2. 10 to the power 8, 10 to the power 8 will cancel. So lambda 2 will be 1.6 into 500 divided by 2. So it will be 0.8 into 500, that is nanometer. So option A is correct. Next one, plano-convex lens of refractive index 1.5 and radius of curvature 30 centimeter is silvered at the curved surface. So it is behaving like a concave mirror. Now this lens has been used to form the image of the object. At what distance from the lens an object should be placed in order to have a real image on the size of the object. First calculate the focal length. First calculate the focal length of this concave mirror form. Oh, this one is ray optics. Mr. Ray optics. Just say R by 2 reflect করে আবার ফিরে আসছে 2 মিউ হয়ে যাচ্ছে R by 2 reflect করে আবার এদিকে আসছে See, since the curved surface is silvered, then light will reflect back, and as a result, when this type of situation comes in a plano-convex lens, then focal length of this combination will become R by 2b. This formula you have to remember that geometrical optics is so many formulas are there for the refractive index. All these formulas don't try to calculate, just remember that if this surface is silvered, then it will be R by 2 mu. Then R is given 30. 2 mu means 2 into 0.5, that is 3. So it will become 10. Now it is behaving like a concave mirror, focal length 10 centimeter. So at which position object should be placed such that it will produce image of same size? Center of curvature means twice it. So the answer is 20. Other questions. 87. Acha, in the question number 87, there is one thing wrong. That is not milliampere. It should be microampere. Then the result will match. Otherwise, the power will not match. If it is microampere, then power will match. So first in this case it is given that half mv square kinetic energy, that is equal to, in vacuum normally, so it will be half mv square equal to q into potential difference. So it will be 5000 into 1.6 into 10 to the power minus 19. Okay. Now multiply both sides with 1m. So it will become m square v square equal to 2 into 5 into 10 to the power 3 into 1.6 into 10 to the power minus 19 into 1m. Okay. Then take a square root to calculate mv. So mv will become 2 into 5 10, 10 into 1.6, that is 60, 16's root, that is 4. This one is 10 to the power minus 16, so that is 10 to the power minus 8. We will change the unit later. Into m. This is not meter, this is mass. Okay, don't get confused that this one is meter, so I will better to write it with the multiple sign. Square root, m square root. This one. Okay. Now we calculate the number of electrons striking. Number of electrons striking is total charge by E, that is current IT by E. Incident current is given 50 into 10 to the power minus 3. So it is given 50 into 10 to the power minus 3 into electron striking the surface, the photons, that is per second. So into 1 second divided by charge of the electron, 1.6 into 10 to the power minus 19. This one is n. Number of electrons striking the surface per second. Now if I calculate nmg, this is force. Number of electrons striking per second and change in momentum during each collision. Then nmv will be the force. So it will be 50 into 10 to the power minus 3 into 4 into 10 to the power minus 8 divided by 1.6 into 10 to the power minus 19 into root over of 9.1 into 10 to the power minus 31 mass of the electron. This term 4 into 50, that will be 200. Okay, divided by 1.6. From this, if I write this one 91, then it will be 10 to the power minus 32. So root 91 will come. then remaining powers will be 10 to the power minus 3, this 10 to the power plus 16 minus 8 and another minus 16 will come, so it will come, multiplier will come. Now calculate this one. 200 by 1.6 into root 91. Just calculate an approximate value. It is coming. Option A. Just tell me this value. There is calculator in the tab. Calculate 1.19. Apart from this multiplier, just calculate this part. 200 into root 91 by 1.6. Only this part. One point 1.192 here. So 1.9.4 like this. This one is coming now. After dividing this one by this one, so that's why I am saying that it can't be 10 to the power minus 8 multiplier. So that's, if that is micro ampere, if the current is of the order of microampere, there will be additional 10 to the power minus 3. Then it will become 6. As soon as it will become 6, so then another factor will come and this one will be another 10 to the power minus 3. Then this one and this one. Then it will be 1.1924 into 10 to the power minus 8. Otherwise it will become 10 to the power minus 5. Ten to the power 6. So that is actually microampere. 50 microampere. Okay. Question is correct. It is given that 50 into 10 to the power minus 3 milliampere. Another milli means 10 to the power minus 3, another will be there. Question number 88. In Bohr model of hydrogen atom, Which of the following statement is correct? Oh, incorrect, sorry. The radius of the nth orbit is proportional to n squared, that is correct. The total energy of the electron in nth orbit is inversely proportional to n. It is incorrect. Inversely proportional to n squared. Next one. There is a charge given minus Q3. There is another charge minus Q1. There is a charge plus Q2. Now, X component of the force on minus Q1, that we have to calculate. First thing, this Q2 will exert a force on this, and that will be attractive because this is positive, this is negative. So this force is acting along this direction. Okay, so let us write this force is given by 2. So it will be F1, 2. Force on 1 given by 2 along this direction. Okay, so this is already along X direction. Now, the force given by Q3 on Q1 is repulsive because both have the same sign. This one is F13. Okay, repulsive. Now we can take the component. The component of this one component is along this direction, other component is along this direction. So we require only the X component. This angle is theta mentioned. This angle is also theta. Then, so this component will be F13 sin theta. This component is cos theta. That is not required. So total X component of force on minus Q1 will be F12 plus F13 sin theta. Okay. So we write only the magnitude of this component because direction is already calculated from the vector. So while we will only write the magnitudes, then we can write it is F12. It is K Q1 Q2 by distance square. This is B square plus K Q1 Q3 by A square sin theta. So we write only the magnitudes, no more sign. Because if you put the sign again, then it will be wrong answer. Because from the vector resolution we have already determined the direction, so no need to put the sign once again. Then from this we can write Fx equal to KQ1 Q2 by B square plus Q1 by A square sin theta. So it is proportional to this part. This is not K, this is Q3 by A square sin theta. So option B is correct. Q2 by B square plus Q3 by A square sin theta. Question number 19. Let's solve question number 90. See, this graph is given. Theta, this angle is theta. This is I, this is theta. See, along y-axis V is plotted, along x-axis I is plotted. So slope of this graph represents the resistance. So we can calculate that for the first, this one, resistance is R1 suppose. So R1 equal to tan theta. Then for the second graph, what is the angle with the x-axis? It is 90 minus theta. So R2 equal to tan 90 minus theta, that is cot theta. Then these are the resistance of the material at temperature T1 and T2. Let us consider their resistance at 0 degree Celsius will be R. So R1 can be written as R into 1 plus R2 can be written as R into 1 plus alpha T2 minus R into 1 plus alpha T1, that is equal to cot theta, that is cos theta by sin theta, minus tan theta, that is sin theta by cos theta. So we just subtract R2 minus R1. R2 is R into 1 plus alpha T2 and R1 equal to R into 1 plus alpha T1. Alpha is the temperature coefficient of resistance, where R is the resistance of the conductor at 0 degree Celsius. Clear? Now Then if you multiply and open the bracket, then R will cancel. First R1 R is there, 1 R is there, it will cancel. Then remaining terms will be R alpha T2 minus R alpha T1. So R alpha can be taken common. Then it will be T2 minus T1. Then this term will be cos square theta minus sin square theta divided by sin theta cos theta. So multiply a 2 here and divide by 2. Okay. Then R alpha T2 minus T1, then it is 2 into, then bracketed term cos square theta minus sin square theta is cos 2 theta, and this one becomes sin 2 theta. Okay. Then we can write T2 minus T1 equal to 2 by R alpha into cot 2 theta. So this entire term is constant. So T2 minus T1 is proportional to cot 2 theta. Okay. You can take a small break. Mock test 56. 56. Okay, mock test 56, question number 1. The ratio of magnitude of instantaneous velocity and instantaneous speed of a particle is always equal to 1, because magnitude of instantaneous velocity is the instantaneous speed at the any point. So their values are equal, so ratio will be 1. So option 3 is correct. Next one, in a thermodynamic process 120 joule of heat is added to a gas and work done by the gas is 70 joule. The change in internal energy of the gas in this process, just you have to subtract. So it is 120 minus 70, that is 50 joule. Because from first law of thermodynamics we know that dq equal to du plus dw. So dq is given and dw is given 70, so du is 120 minus 70. Next one, a particle is moving along x-axis under the influence of a variable force F equal to 3 by x square, where x is in meter and F in newton. The work done in displacing the particle from x equal to 1 to x equal to 3 meter. Just you have to integrate W equal to integral F dx, that is 3 by x square dx. Displacing the particle from 1 to 3. So it will be minus 1 by x, its integration, then 1 to 3. So it will be 3 into 1 minus 1 by 3. I just change the limit because there is a minus sign. So it will be 2 by 3, that is 2. Okay. Then question number 4. Water is flowing through a horizontal tube of non-uniform cross section at the point of smallest cross section of the tube. Smallest cross section means area of cross section is small. Means from the equation of continuity we know that A1 B1 equal to A2 B2, that is A is inversely proportional to B. So smallest cross section means velocity is maximum. So velocity increases and as a result pressure will decrease. So maximum speed and minimum pressure. Because velocity increases means kinetic energy increases, and then the pressure energy will decrease to maintain the Bernoulli's theorem. The total energy remains constant at any cross section. So if the area of cross section is small, velocity increases. Velocity increases means kinetic energy increases. So pressure energy will decrease. So it will be maximum speed and minimum pressure. Option 2 is correct. Then question number 5, diagram is not there, so we cannot do anything. Question number 6, a parallel plate capacitor has a capacitance 80 microfarad in air and 140 microfarad when immersed in oil. The dielectric constant of the oil is C prime equal to C by K. So from that you can calculate. C prime equal to K times C. So C prime equal to K times C. So K equal to C prime by C. That is 140 by 80. By 4, that is 1.75. Because when dielectric is filled between the plates of the capacitor, then capacitance increases. So previously C, now it will be C prime, that is K times C. Question number 7. A circuit consisting of a resistance and an inductance coil in series connected to an alternating voltage source of 20 volt. The voltage across the resistance is 12 volt. Then the voltage across the coil is. V square will be equal to VL square plus CR square. From that you have to calculate, because R and omega L are not along the same direction in the phasor diagram. They are perpendicular to each other. So total voltage square equal to VL square plus VR square. You cannot add simply V equal to VL plus VR, because there is a phase difference because of the presence of the inductor. So now V is given 20. So it is 400 VL square plus VR square is 12. That is 144. So VL square becomes 256. So VS will be 16 volt. Okay, it will be 16 volt. Then two identical blocks P and Q, each of mass m, are connected with a light spring and are kept initially at rest on a smooth surface. A third identical block moving towards positive x-axis strikes block P elastically. Then the center of mass of P and Q. See, P and Q connected with a string is a single system. Now when another particle, another object comes and strike it, it is an outside object, so its force is the external force. So in the presence of the external force, center of mass cannot remain at rest. So option 1 is correct, will move towards x-axis only. Because the force is along x-axis, so center of mass of the previous PQ and the spring system will move towards x-axis in the direction of the force. Okay. Because force exerted by the third block is not a mutual interaction. If it is mutual interaction, then center of mass will remain static. Since it is not mutual interaction, it is an external force, so the center of mass will move in the direction of the force. Then question number 9. Assertion: the focal length of a lens changes when red light is replaced by blue light. Obviously, because color changes means refractive index will change because wavelength changes. Reason: refractive index of lens depends on the wavelength of the light used. That is also the correct, and it is the correct explanation of the assertion. So option 1. Next question. Question number 10. Just complete the free body diagram and calculate. A block of mass 10 kg is hung with the help of a light string as so shown. The tension in string 1 is that you have to find out. Two strings are there, and remember, tension in the strings are different. So in the string 1 you have to calculate the 3 strings are given, T1, T2, T3. You have to calculate T1. The first string, another string, there is a block of mass n. This is string 1, so we draw its tension T1, string 2, tension T2, string 3, tension T3. There is NC. Okay. Now, two methods you can adopt to solve this problem. One, by taking the components of T1 and T2. Other, by using Lami's theorem. It is easy to calculate using Lewis theorem. See, for applying Lewis theorem, just draw a line, horizontal line here. This angle is given 37. This one is 53. Then what is the value of this angle? Find all these angles about this point. So this angle is 90. Now this angle we know, again 53. This angle is 37. Okay. Now from this point, there are three forces, T1, T2 and T3. And under all these forces, the system is in equilibrium. So we can write T1 divided by angle opposite to T1, this one. This one is 90 plus 53. So this one T1 by sine 90 plus 53. That is equal to T2 by corresponding angle, but that is not required. T3, but we know that T3 should be equal to mg. So it will be mg divided by the angle. Angle is T3 is opposite angle, that is 90 sin 90. Okay. Then this one will be T1 cos 53. This is equal to mg. Second quadrant means sign is positive, and since it is odd multiple of 90, so it will be cos. What is cos 53? So it will be 3 by 5. Now put the value of m. M is 10, G is 10. So it will be 16. Otherwise, if you do the component calculation T1, T2, the answer will come, but after long calculation. Directly try to apply Lewis theorem. And while you are taking Lewis theorem, in this setup, T1 its opposite angle, entire angle. T2 its opposite entire angle. T3 its opposite entire angle. Because this setup in equilibrium can be converted to a triangle when all sides are taken in same order. Means zero force, net force zero. So in that setup you can also apply Lewis theorem. In this setup you can also apply Lewis theorem. Because if you shift the vector parallel to itself, this T3 brought here, T2 brought here, T1 brought here. So this is forming a triangle when all sides are taken in same order. So resultant of these forces will become 0. vector sum of all these forces. When the third side is taken in opposite order, then third side represents resultant. If third side is also in the same order, then the sum will become 0 because it starts and terminates at the same point. Question number 11. A small pencil is placed in front of a concave mirror of radius of curvature 20 cm. If the image of the pencil is formed by the mirror is inverted, inverted means real image formed. Okay, then the distance of the pencil from the mirror may be equal to. See, radius of curvature is given 20, so focal length is 10. And if the object is at a distance greater than focal length, then only real image is formed. Because if it is less than focal length, then virtual image will be formed. So it should be greater than 10. Two options are greater than 10. One is 20, another is 12. So option 4 is correct. Both 1 and 2 may be possible. Okay. Now in this type of situation, if you write option A is correct, don't expect a 50% mark. Then question number 12. Magnetic flux linked with a coil is given by the equation phi equal to 3t square plus 4t plus 1. The phi in Weber, t in second, the induced EMF in the coil at 2 seconds. Just calculate t equal to minus d phi dt. Just magnitude you have to calculate. So we will calculate just mod t. That is d phi dt. Phi is given 3t square. So it will be 6t 4 at 2 seconds. 2 seconds means 12 plus 4, 60 volt. Just calculate d phi dt and put t equal to 2. Next one is also very easy. When two resistors are connected in parallel, their effective resistance is equal to 10 by 7 ohm. Means R1 R2 by R1 plus R2, that is given 10 by 7. If one of the resistor is 2 ohm, say R2 is 2 ohm, then find R1. By 7 to 10 cancel 5. So it will be 7 R1 equal to 5 R1 plus 10. So 2 R1 equal to 10, R1 equal to 5. Parallel combination of two resistors, that is equivalent is R1 R2 by R1 plus R2, and that equivalent is given 10 by 7, and one of the resistor is given 2 ohm. Then what will be the value of the other resistance? So R1 we have to calculate, so 2 and 10 cancel 5, so 7 R1 equal to 5 R1 plus 10. So 2 R1 is coming 10, so R1 equal to 5 ohm. Next one is a standard question for an ideal diatomic molecule, Cv equal to 5 by 2R. That is the formula. Consider the following statements. Gravitational potential energy at 2 point of a 2-point mass system is negative. Correct. Option B. In the case of spherical shell, the plot between gravitational potential and distance from the center of the shell is continuous. Obviously continuous, because spherical shell, the plot between gravitational potential and distance. Inside the shell, potential is constant. Inside the shell, potential is constant, and outside it is falling with 1 by r. So at this point, it has a negative value on the surface, so it is continuous. Okay. Now, gravitational field intensity due to Earth increases with increasing altitude. That is wrong, because it decreases with the increasing height above the Earth's surface. So option A and B only are correct. That is option 1. Acha, can you tell me, at this point it is continuous, but is it differentiable at that point? If in a graph there is any point is continuous, still it can be not differentiable. It is continuous, but still the situation arises that you cannot differentiate it over there, because it has a kink. Differentiation means a tangent you can draw at that point, and that should be a unique tangent. Now if this point arises, how many tangents you can draw? Someone say this one is a tangent, someone say no, this one is a tangent. Tangent means a line which touches the curve at only one point. So this is a kink point. So at that kink, many tangents can be drawn. So you cannot find unique tangents. Since you cannot find any unique tangents, you cannot say any unique rate of change of the function. So it is not differentiable. You cannot differentiate the function at that point. But still it is continuous. Question number 16. Two wires of same material and same cross section, everything same, are stretched by the same force. If the lengths are in the ratio 3:4 respectively, then their elongations are in the ratio 3:4. Why? Because F by A, y equal to F by A divided by delta L by N. Now it is delta L by N equal to F by AY. Now force same, area of cross section same, y same, means delta L by N equal to constant in both the cases. So we know that delta L proportional to, so the ratio of the lengths and ratio of the elongations are same. So it is 3:4. In the given circuit, the energy stored in 5 millihenry inductor in steady state will be. See. Half Li square will give you the energy stored. So that is half 5 millihenry means 5 into millihenry, and so we will not convert. So it will come in millijoule. I will keep the same unit, millihenry. So 5, I is 2. Current is 2, that is 10 volt by 5 ohm. Because Since it is a DC flowing, then inductor coil will not offer any resistance for DC, because for DC omega equal to 0. So inductor coil resistance, inductive reactance, that is omega L, that will be 0. So that will behave like a short circuit path. So current will be here 2 ampere, because 10 by 5 is 2, so 2 square. So this will cancel, so it will be 10 millijoule. Next one, see, I1 and I2, the two close parts, they are carrying current in the same direction, so they will attract each other. Opposite side, this one will repel by the straight wire. But since this part is closed, so the force on this part has higher magnitude. So the entire loop is attracted towards the straight wire. That means towards negative I cap, negative direction of x-axis. Because this one, next one, a particle is executing simple harmonic motion such that the displacement from mean position is x. The total mechanical energy of the particle is, it is not depending on, because total mechanical energy is half m omega square a square, where a is the amplitude. Okay, so it does not depend on x. You can also calculate this one, that kinetic energy half m v square, potential energy half k x square at that particular point. So this is the total mechanical energy E. Now if you calculate v square equal to half m, that is omega square into a square minus x square, and this one is half k is m omega square into x square. So when you add, x will cancel, it will be half m omega square capital S square. So it does not depend on x. So the correct answer is x to the power 0. The frequency of the first line of Lyman series in hydrogen atom is F. The frequency of the corresponding line emitted by the doubly ionized helium ion will be. Okay? 1 by lambda, that is equal to R Z square into 1 by Ni square minus 1 by Nf square. Okay. Then for the first case, 1 by lambda, that is equal to R Z is 1 for hydrogen. It will be 1 by 1 square minus first line 2 square. This one. Then for the lithium, let it be 1 by lambda prime. It will be R Z. Z is now 3. So it will be 9. 1 by 1 square minus 1 by 2 square again. So this factor will cancel when we will divide. So it will be, so this is equation 1, this is equation 2. I divide equation 2 by equation 1. 2 by 1, that is 1 by lambda prime divided by 1 by lambda. So it will be lambda by lambda prime. It will be equal to 9. Okay. Lambda by lambda prime. 2 divided by 1 we have this. Calculate. 2 divided by 1. Equation 2 by equation 1. So it will be 9. So ratio of the wavelength. So it is inverse of the ratio of frequency. That is f prime by f. 9. So f prime equal to 9f. Because frequency equal to c by lambda. So inverse of the wavelength ratio is the ratio of frequency. Question number 22. A straightforward application of Lenz-Neckar formula. Just calculate from this. 1 by f equal to mu 2 by mu 1 minus 1 into 1 by r1 minus 1 by r2. Biconvex. So this 1 by f is power. So that thing you have to calculate. Refractive index of the lens 3 by 2. So this is 3 by 2 minus 1 means half. 1 by r1. So first surface 10 by 3. 10 by 3. By 3, and second surface, since it is biconvex, second surface is a negative sign of the radius of curvature, so it will be 1 by 15.